machine learning problem, such as the problem the input to the model, the expected output to the model, and so on. In today's presentation, this would be a bit more high level, but looking more at the importance of really defining certain success criteria for our machine learning project. What the aligned metrics will look like, that is metrics aligned to the specific problem we are trying to solve, what the expected results are, what are some of our failure conditions. Also, when it comes to risks, the impact of risks and errors in the model, the readiness in terms of deployment and implementation. How do we know when a model is ready to be deployed as well? Now, this is not the only way of looking at it, but one useful way of thinking about it is in two small documents, even though they could all be part of a larger document. One that's the success card, and another that's a risk radar that will look at what items that define the success of the project, and the other focusing on the risk. So just in 5 short points, by the end of this, the idea is to help you appreciate the importance of important is that you choose the right key metric for the problem you are solving. How important set certain target metrics based on various considerations, such as but not necessarily limited to something like launch, 90-day long run numbers. We'll look more into that. But basically, expectation at which point the model is ready to enter the market or testing or pilot in some way. Understand the importance of clarifying failure conditions and those responsible for identifying and responding to those failure conditions. Hurt by the model or just ignored and quite left out. And finally, we'll look at the importance of assessing and in a structured way when your model data and implementation are both feasible and ready to start implementation, but also ready to go to market. So the model, as we'll see, can be technically correct in a certain way, but also be wrong in another way. And from another perspective. And so what perspective you're looking at from, I'll give an example later, is very key. So we are going to address 2 questions. What success looks like clearly, and what could also go wrong. And of course, the outcome will be looking at it through the lens of those 2 summaries that I spoke of in terms of the success card and risk radar. So when it comes to that, we need to think about and keeps repeating and through our last lecture, but really it's still key that we pick the right metric for the job. It's very easy to get that wrong. That we define our expected results, right? For instance, when we launch, what is the minimum performance of the model required for us to be able to launch? Define failure conditions, or like we look at like reality change, the performance of the model changes. At what point do we say is it failure? Is it 10% error? Is it 20% error? These are all things that need to be carefully considered because often by the time um, things are going wrong, it's not the time to then deliberate and figure those things out. And now when it comes to choosing what we are measuring, um, as we saw in the last lecture, the model only sees in terms of the formulating the problem. There's a way we see the problem, and we have to be cognizant of that in terms of how the business sees the problem, engineering sees it, how the user experiences it, but at the same time, be able to translate it to what the model also sees. So, I mean, I'm using the word see loosely, but for instance, when you're looking at the engineering business layer, you're talking about, okay, the business, what is it trying to solve from a business perspective? So that could be, for instance, the business wants fewer fraud losses or more loans approved without bad debt or wait time or less spoilage. From the user interest, and this also will then inform the downstream decide metric you will use or measure you use to decide if a model is performing or not. From a user perspective too, a user, for instance, using that same fraud issue, while the engineer or the business is thinking about having fewer fraud losses, the user too is concerned about making sure that their legitimate transactions are not blocked, right? So as we saw in our last conversation, sometimes you need to balance several things at the same time because if you want to make sure that a lot of most users don't have their transactions blocked, that may come with the downside of allowing through some transactions that may be fraudulent a bit more liberally. So all these things need to balance from the user's perspective. Just saying, for instance, from the medical point of view, you got a diagnosis on the same visit and it was correct. These are all real metrics or real things that tie into exactly what the user is looking for using to judge the quality of the. As we know, at the level of the model, then it comes back to the things you'll be learning about much more during these ML training sessions about things like precision report, F1 score, and so on. So for instance, let's take a look at the importance of picking the right metric. So here's a hypothetical scenario where let's say a team in Kumasi is training a machine learning model to spot diseases on tomato leaves from a photo of a farmer. So they take 10,000 photos and the model is right 99% of the time, right? So because out of all the 10,000 photos, once they train and it's labeled, once they train the model, they see that, oh, out of all the times the model is being used to make an inference, 99% of the time is correct. So they can go and report that, oh, our model is 99% correct. But this could totally be misleading for what the person consuming and the need of the model requires. For instance, here we could get that metric by just always saying healthy. So what is it saying that only one of if if only one of every 100 leaves in the test set actually has that disease, then the model can simply say healthy, be right 99 times, right? So, but the accuracy doesn't really mean anything to the person because another way you could look at it is, oh, um, out, out of the deceased leaves, it was able to find none. So you can just imagine the two different viewpoints, right? 99% accurate, that's 100%. It's also true that of the dangerous case or the actual disease you are looking for, it was able to find zero, right? So what metric you are tuning for and what metric you're optimizing for and what metric you're reporting is very important. It could even verge the uh, um, on the edge of fraud. right? If you are not careful, right? Because you can imagine a scenario where if there was a lot at stake and your company boldly went to report because of a data scientist who didn't know what was doing that, yes, our switch is 99% and go and get a contract, and then they find out that actually when you were, even the data you were reporting, it was zero. But was, you can imagine that it would even come out as fraud. So the lesson here, one way to look at it of, a lot of these things, you look at it from different scenarios to try to figure out what your metric should be. So one kind of indicator that a metric is quite key and you should hone in on it is that, usually when there are mistakes with that metric, someone gets hurt and there are adverse consequences of that. Like in this case, the recall really hurts someone, right? That you scanned my leaves and you found zero diseases, right? That is what hurts the farmer, right? And now the numbers that I spoke about, it's the machine learning model training process and life cycle is not just a one-time thing, right? For instance, what you have even during training might be different and might experience some small drift and small changes when it goes into production, and it has even been in a market for a while. So, for example, when you're training a system or when you're defining certain specifics of the solving this problem, it's important to make certain things clear, like once you've identified your metric, then for that metric, what is good enough, right? You can launch, you can do pilots and so on and start getting real users. Because, well, it can also validate what you are doing in terms of the product, but also help get more data and real world um, use as well. You should also consider that, in 90 days, yes, it could be that you get more real world data and the model even gets better. It could be that it deteriorates a little bit because, regardless, it's still new data and it could have some differences from what you used to train. A good enough scale where the model can be, it's almost even like a fault tolerance range, right? Where the model can be trusted in production and can actually be used practically. And then it can also help to have a long ambition, right? So based on realities and realistic literature review, understand of the problem, what is a metric that the team is really trying to aim towards, and that if that metric was hit, then the team knows that this is a very big win and it's really great. So usually that is also useful to really kind of be able to look to and know where you are going. Speaking to why it's important to do some of these things, there's another scenario, right? So you have a different distribution center, they are trying to predict delivery delays, right? And the team is really working on building a model to predict. So if they're doing well, they get accuracy 65%, 71%, 74%, and they're going great, they're excited. So they keep improving it, right? What they know is that they are pushing the number up, and every time they push the number up, the team feels very happy that yes, they've done a really great job. But then the model is, you might notice that maybe the model might not launch because nobody defined, sat down and really thought about what accuracy do we really need for this model to even get to the market. So once can come in and are consulted, you may realize that, 70% from how we've looked at our business and all the associated considerations, if we have 70% accuracy, then we can launch, right? And you can see in this example that, a consideration like this unlocked the launch. I was able to let the model launch immediately. So the point is that sometimes what can hold development back is not having a clear understanding of these things. Um, Also, like with the success conditions, with uh, failures, right? We have to really explicitly say, for instance, what number would force a rollback of the model from one version to the other. Right. Again, when the when the model is performing badly, in organizations, certain deliberations can even take weeks, right? So for someone to notice that, oh, the model is performing badly, what do we do? But is it even bad enough? By that time, it could take a week or two, even for the organization to now sit there and decide those things. But it could be too late, losses could be incurred. But if it was a consideration that was made prior, then as soon as a certain scenario is hit, there can already be procedures that are kicked off, well defined to handle such a scenario, right? Um, Fill blank deploys a machine learning model, and it goes well, approval rates are going up because suppose they believe they're in their model, the model is doing a good job because the defaults are fine, right? But then in the like in start rising, so now all of a sudden more people are not paying for the back their loans, and in 5 months, even the people than the launch, right? But let's say that no one had agreed on an organizational level what default rate will now trigger some action, whether it's a rollback, whether it's to an earlier version of the model, whether it's the rollback to the earlier system, all the various backup or failure modes. This will really happen. That each week, you know, um, this thing is happening. But I can see that over several weeks, every week, even teams can be arguing, is this real? Should we pull the model? Should we let it go? Right? Um, and all those things that end up leading to several losses before even any decision could be made. So it's very important to also define models the model, past the quality threshold that we are comfortable with dealing with. So when it comes to the success card or the success summary or summarizing certain key things that we are looking at when it comes to defining the success of a model, number one, obviously the goal, even in the previous document we saw, I mean, the goal is what is going to inform everything else. The headline metric, as we discussed, usually based on the use case, just like with the example of the deceased plants, the metric that will truly tie into really exposing the truth about what a stakeholder is interested in and what is really impacting their need has to be key. The launch bar, at which point there's acceptable to shape the model, a 90-day target or a medium-term target you could consider of within what bands do we expect as we are hitting the real world, this model to stay within, and also a long-run ambition of if in terms of the feasibility and the ambition of the team and our effort, this is the number that we are looking at. Considerations like guardrails. I'm sorry, I didn't mention guardrails earlier, but guardrails in this context, I mean by other metrics which may support the bands within which your model might operate. So for instance, when it comes to something like credit scoring, yes, maybe your accuracy is good, maybe your recall is good, maybe your precision is good, your ROC score is good, overall fine. But what if you notice that, particularly in the north, there's a certain discrepancy where over there, their accuracy drops below a certain threshold, or precision drops before whatever metric you're looking at drops below a certain threshold. So you could see, even though overall, let's say the ROC score is what is great, there could also be another rule that if the ROC score for a particular region was also to go below a certain number, right? Or if you notice that when we take men and women, the rate at which they are getting loans is becoming wider. It has widened, right? Those are all extra metrics and guardrails that we can put into place and define. Also expresses the requirements that we need of our model and how it should perform in the real world, right? So again, just to highlight that at the end of the day, your business use case you have to translate to metrics. You can say, okay, I don't want the model to discriminate, but what does it also mean in terms of metrics, whether a model is discriminating or not? So, I mean, this is probably not the time to dive into the details of those things, but as you um, go ahead and learn about more metrics and all that, you might consider asking yourself that, oh, the metrics are, you're seeing when it's good or when it's bad overall. But, well, for instance, what can also help me look at maybe that what will show that the system, how do what metrics can I use to actually capture that as well, right? Of course, I'm not for failure. Failures happen, and part of a successful project is preparing for failures successfully, and be so that you can handle them gracefully when they happen. So mapping out various failure conditions, um, along with the owners of those who will deal with those um, when the time comes, is also something that is key. Right? This is also related to the risk section that we'll jump into. We started a bit late, and the previous one has been quite short, so I will get power on. Instead of the break that we were sliding about. Okay. So now the risks, right? The risks are what are the things that could, whether maybe some are a bit more explicit than others, sink a project or cause it to fail, right? So we're going to look at it, let's say, through the lens of four key pillars, right? In this particular talk. The first one is the impact, right? Yes, who is affected by the model? Who is the model helping? But also now look at the risks. In what ways, right? Model readiness. Okay, you're about to embark on this machine learning project. Well, is ML even the right tool for the job? Do you have the right team? Do you have the right budget, right? Data readiness. Okay. There are machine learning models that even are proven in literature and through even industrial, um, um, let's say, information from industry that this model can solve this problem very well. But do you have the data, right? Can you continue getting that data? What is the quality of that data, and so on and so forth. And then also certain risks around implementation. For instance, we were in the real world, there are all sorts of considerations, such as speed, right? If my machine learning, it could, if I'm designing a machine learning model for fraud, well, it could be a risk that, well, transactions have to be processed in a certain period of time. What if the model I come up with is not able to uh, have the right latency and the right speed to be able to fit this need, right, of actual implementation? How about integration? It needs to be integrated into the actual, at the end of the day, whatever ML, so how is it going to be integrated? If it's something that, let's say, edge without internet, well, okay, then it means that maybe it would have to need a certain amount of efficiency. It would put some um, limits to its size and so on and so forth. As well, for instance, what's the cost, right? What's the cost of training? Um, some of the risks or associate as for monitoring and support, they also have to do with observing things going wrong, and then of course support being able to address them once they do. And it's also, so in implementation, how are you going to monitor the model, and how are you going to support, or what does support look like when there are problems, right? So yes, so when it comes to the impact, right? The impact is both ways, right? Even though we're looking at risk right now, yes, you can look at when it works, right? So when it works, it's very beautiful, you know. So a medical model, who are the benefits, you know, patients, customers, it can improve their lives, right? It could be a very good skill that a lot of people really use it. It can impact a lot of lives and so on, right? Um, it's the, or even the time to see benefit, right? For instance, not to hammer on the credit scoring example, but I'm sorry, I'm from the fintech industry. So um, if, and by the same with, let's say, even the fraud, right, and so on, that, um, okay, what is the actual benefit in practice for the company? Is it that over 6 months we'll see that, oh, maybe we saved X amount of dollars or so on? How long will it take us to really see a return that maybe, right? That also is relevant in defining, especially now when you go and check the costs as well of, or on that side of the cost of implementation and deployment and so on, right? Right. Who are the direct casualties, right? Um, if a wrong prediction happens, right? Like who suffers, right? Um, or suffering can be disproportionate. Let's say, for instance, again, credit scoring. Um, if if you are right, you know, the person, the business benefits in the sense that, okay, it has a better accuracy of scoring people and it affects their bottom line to some extent, right? I mean, on a large enough scale, yes, it could be quite significant, but on the individual scale, you could, in quote, argue that, okay, yes, but when you are wrongly discriminated against, right, that one in a sense can even be more devastating, right? And in some instances could also even be in a scenario where you have the benefits being carried by a certain class, and then you have the the cost of a wrong prediction being borne by another group or another class, which, you know, really goes back to talking about unfairness and all those scenarios, right? For instance, businesses benefiting, but common individuals being really disproportionately affected by a wrong prediction. You could also imagine a medical use case and so on. Also, hidden harms, right? Um, could be due to some scenario that you might not anticipate. Could you find yourself in a situation where certain regions people who speak certain languages, people in certain income brackets can become now even worse off quietly without anyone knowing, right? And this is also now speaking to the fact that often it's not enough to just take the stakeholders or the groups that are interacting with your machine learning model as one big whole, right? Um, if you are only looking at the one big number, you might never notice that some group, maybe a religion or maybe a region, uh, is actually being worse off. So in the loan example, I know over and over again, but in the loan example again, your uh, your profits could be going up. Even more people in the country are now getting loans, but maybe if you're in a certain region, you speak a certain language, and you are a woman or you're a man, you notice that those people rather now are getting denied loans more than they even did before you came into the picture, and it could be something that if no one looks into it too deeply, it could be quiet and go unnoticed in society, right? Um, and also really looking at the reversibility and being aware of how you design systems that, there are different costs, right? And different degrees of reversibility once you make a decision. And decisions that cannot be reversed or can have an appropriately high impact will then need further mitigation. For example, you could mandate human in the loop at all times, right? So this another scenario where let's say you're a small lender and you have been operating in Accra and Kumasi for a long time. Now, in the last year, you went national, but you were operating in Accra and Kumasi for maybe 10 years, right? So now you go and train a machine learning model on all of your data, right? You might not notice that, oh, actually, my data is not anything. Sometimes massive data tells the truth, but sometimes massive data can even just drastically lie, right? So in this is an example where yes, you can have so many people, but you're not taking into account that the people you have, they are majority only in Accra and Kumasi, right? Where certain conditions might be different than let's say Tamale or Bolgatanga. So if the in this case or this scenario, it took, let's say, 6 months and an external audit, after which one, then now the regulator, because there are regulators that also look out for these things. So if you keep it quiet, you think that, oh, everything is going great, approval rates overall have risen, this is amazing. Regulator now can come in and think who thinks about some of these things that you have ignored and really notice that, wow, there have been entire populations that could have even dropped by even a third, or I mean, just a hypothetical number. But the point is, they could be facing significant adverse impact without you even knowing because the number overall looks so good, right? And um, one thing, yes, to remember is that yes, the benefits are easy to, especially when it comes to ML and engineers and the way we get excited about solutions. Yes, benefits are very easy for us to imagine, but often we tend to, overlook the harms. And so we sometimes need to be deliberate in really sitting down and prompting ourselves to make these assessments. Um, so when it comes to model readiness, right? Machine learning is expensive in many ways, whether it's collecting data, training data, cleaning data, training your models, and so on. As part of looking at the risks and assessing the scenario, let's say if some of you are familiar with literature review at this point, I believe, there are certain things that you can look at even before you embark to um, to gauge where you start, let's say, in terms of the risk of will you be able to use ML to solve this problem, right? we have looked at one angle in the earlier lecture. This is just a slightly different angle, right? So for instance, has anyone solved this kind of problem with machine learning before, right? If yes, then of course, um, unless it's proprietary, but especially in machine learning, unless it's a field that is actually has done quite well, it being a field that has a lot of open source information and out there, so on and so forth. So often it's quite good, not even just common, but good practice to you don't necessarily always start from scratch per se, right? Um, if people have already done some work, release some open source models, you can of course develop your own, come with your own ideas, but also work off of some of the knowledge that they have gained, right? And it also ties more into risk because if I go to my boss and say, oh, this is a problem that has never been solved with machine learning before, well, it could be that it's solvable, but there's a risk versus, oh, I mean, even from literature, this is a problem there have been quite successful machine learning solutions to it. That also informs the risk of of embarking on this machine learning formulation, solution, training, so on journey, right? Also in industry, probably in academia, it might not sound so good, but in industry, yes, it is very common that often our bosses give us jobs and we really rush to do it from scratch because um, you are being trained, and that's the right thing to be able to do things from scratch and understand things at the deep fundamental level, right? Um, but when you meet the business world and now you're looking at cost, risk, so on, speed, you often realize that you might actually be doing, let's say, the wrong thing by oh, there's already a vendor that sells this solution and it's actually based on the price and the business model, it actually makes sense to go with that vendor, right? For instance, one example right now is LLMs, right? Um, if you want to, let's say, if you want to code, right, with LLMs on a certain level, things are changing, so take it with a grain of salt. But generally, it remains true that what OpenAI is giving you, what Anthropic is giving you, is heavily subsidized in many ways, but also the efficiency gains they get and the optimizations they're able to do because it's not just one person, they're serving a lot of volume at scale and so on and so forth. Um, if they are able to host and serve these LLMs. Um, it's much more cost effective than you building a data center in your office and hosting open source LLMs by yourself. They might not be good enough even to do the job. And if you are to get one that is good enough, the cost might be astronomically high, right? Um, it also depends on the degree, right? If you want to code with AI, but maybe at a certain level, not too much high volume. Does it make sense to now put in all this effort, right? So again, knowing the business scenario will also help inform that, oh, this is best to buy from a vendor at this point in time, right? Again, I feel bad even bringing this up in in a machine learning um, course, but it's true. Sometimes, from the business point of view, you building it from scratch is not how you show the knowledge you gained in this course, but you can show the knowledge in many other ways, right? Where even maybe what you are looking at in this lecture might then be even more relevant because now okay, yes, you're getting it from a vendor, but what are the metrics? Okay, do we have some benchmarks internally that we are using to really monitor that what the vendor on our test set, what the vendor is claiming is true. What are some of the risks? What are some of the hidden food guns, right? It's also a very important job. So it's not only, it's not, my point is just that you can show your sense in many ways. It's not always just running to build it from scratch. It's a mistake I've made myself many times. And then open source solutions, right? There happen to be open source solutions that you can build off on, and to make some of these things practical. The reason is because a lot of the time, if you, even in terms of what is a good example? Yes, you can get open source models which are already trained in some ways, especially when it comes to these natural language tasks and stuff like that. But also, there's also benefits in stuff like transfer learning and so on, where you can use open source solutions and then tune them to your particular task, but start with an open source solution which has been trained on quite significant data and has gotten good enough already. A lot of the time, you see this with CNNs where you might have a CNN trained. Maybe you haven't learned what a CNN is yet, but you could have a neural network that is trained for a particular task. Maybe it's recognizing common objects, right, in the world, right? Um, but because it's been trained on so much data, it's learned some very good representations and good way of representing data that makes discernment very good downstream. So then you can use that and then put in that last uh, training to maybe tune it for any particular type, maybe the diseases on crops or something like this. So in this scenario, it's not that you're just copying and pasting an open source solution, but especially in machine learning, in certain scenarios, um, where, especially with, again, these LLMs are also natural language related models, and even computer vision as well, where because of the sheer volume of data and resources needed to get the models to a certain point, this work is already also done and released open source, right? So if you're not aware of this, you can go and tell your boss that, to do this, we need, a million images, we need months of training, which is true, but maybe someone has already done a million images, months of training, and you can take it and then fine tune it, which maybe now becomes tens of thousands of images and days or weeks of training, right? Which then really affects the feasibility of what you are doing, right? Also, um, the team that one has is also very important. Sometimes companies want to get into, everybody's excited about machine learning, machine learning, machine learning. It's also very important, again, to take your knowledge from this class, in my view, and also be able, if necessary, to apply it to really educate a team and an organization of, okay, if you want to go with machine learning and develop machine learning in-house, these are some of the considerations that come with that. And really making sure that, you have a team and the resources that are going to be able to handle all the various considerations, not just one-time experimentation. Or if you could experiment if you want, but if um, if you're thinking more long-term, then probably that's something that you need to be cognizant of. And also, like we looked at in our last lecture, you know, there are rules, heuristics, ML models. Um, how far can you get with handwritten rules, for example, right? Can they deliver a good percent of the value? I mean, this also tied in with us deciding what is good enough anyway. Because if you have a scenario where they can bring 80% of the value and you've decided that 82 is good, sorry, 75 is good enough, then certainly you could start with the handwritten rule and then move on to the ML. So for instance, again, credit scoring is very common because usually a lender is starting to lend to people. They don't have data on people. So they need to come up with some rules from industry expertise, industry knowledge, and so on and so forth, data analysis, maybe some small data that they have. And then that is working and actually bringing in money and already providing business value while you are working on the machine learning solution, right? But if you dive right into machine learning solution without asking, okay, what is good enough, right? You might have missed the chance that, oh, you can actually put a handwritten rule, start making money before as you are even build out the rest of your machine learning capabilities, right? So this is just also another scenario. I mean, some of these scenarios, if you find a loophole in it, you can bring it up, but they're really just meant to illustrate, a more picturesque way, right? So there's a scenario where, let's say, there's a small pharmacy team and they've decided that they've learned machine learning, so they want to predict whether when you have prescriptions, which ones are more at risk of being misfilled than others, right? And so the idea is that they spend several months training a machine learning model that has to takes a lot of features and can predict this. One thing, maybe now it will not stick out, but one thing that might stick out is that if you have 40 features, it's much more difficult to, now interpret the model and so on and so forth, right? Um, but however, what if someone then tries to say, oh, well, out of fun, can I just write a rule-based system, right, that can um, solve this problem? And let's imagine that it just takes three factors: prescriber load, drug class, and weekend shift. And you realize that a rule can now catch 78% of, of the issues, right? At even 1% of the cost, because it's just a simple rule, right? I mean, you can see that clearly what will happen is that the model will be paused, the rule-based system will go live, and the team will probably take much more time, right, to understand the model, the nuances, the data, and so on and so forth, right? Um, so again, the lesson here is that sometimes the right amount of ML is none. We looked at that at last um, lecture as well. But I mean, let's not say it's a hard none, but let's say sometimes it's none, sometimes two. ML can come a bit later, right? And sometimes two, based on the scenario, as for here, explainability, um, especially, a pharmacy is a medical field. If you're not familiar, medical fields even have a higher um, need for explainability in many scenarios, regulation for one reason, and also just the sheer cost of mistakes and so on. So maybe that's also inherent to this example that I didn't really hammer on, that, have been able to have this 6-9 rule with only 3 features. They actually understand. It has a lot of value in that in itself. Um, so now we come to data readiness, right? So um, some of the risks also are around data, right? That okay, so do you have the data, right? Um, what format is it in, and all those things? How can you have access to it also matters. Is it labeled, right? How many are labeled, and so on and so forth. How fresh is it, right? Um, does it change? Is it a type of environment or a type of data that the underlying thing it's representing can change um, out of the blue? Or is it something that maybe it's more stable? Is it something that we can get fresh data for, right, and continue training? Or, and the example will help us understand that consideration more. So I'll just wait to get to that. But also number four, like I think I mentioned the last lecture, but again, as engineers, yes, let me just not speak too much about that, but just say that as engineers, we don't think about this stuff. But when you're in the real world, um, please ask yourself, are we actually allowed to use this data? Um, Surprisingly, a lot of times it's very annoying how many times you find out that the answer is no, or there are caveats. It's often actually quite depressing because you might get a high of, we are going to solve this problem, and then you realize that you're dealing with data that's heavily regulated, and there are all sorts of considerations. But it's better to know than to be a blissful idiot and then get really shot in the foot, right? So this is a scenario, right, of let's say an intercity bus company. They build a model that now is going to predict arrival time for the bus in Accra, right? And so they have GPS data over 2 years, and they have prepared it. They've analyzed the data. They've taken a lot of work into making sure that their data set is really, really great and very well labeled and very clean and well structured. So it's a very, you can imagine that it's real data over 2 years, perfectly collected, lovingly, with all the, making sure that it's pristine, right? Genuine data. Now they launch it, and 2 months after, let's say they close a section of N1, right? And now the traffic pattern has shifted, right? And all of a sudden, just like by a snap of a finger, even though we are talking about perfect, the best training data you can get in life over those 2 years, the predictions can now be off by 40 minutes, right? Just because now the traffic pattern has changed. And now, of course, social media complaints, people are making noise, and so on and so on. So this is a scenario where, okay, if you are aware of thinking of these edge cases, then for instance, yes, you could. So this is the first one. A basic one could be that let's refresh every month, right? But even every month cannot necessarily deal with something like the N1 closing. So you could say, okay, let's have something like drift alerts, right? Where as soon as the ETA of that's estimated time of arrival, the error between what is predicted and what is real becomes wide enough, then we are going to trigger whether it's an alert or retraining and so on and so forth, right? As an indicator that the underlying data and assumptions have changed, right? And this also ties back into the thing of not only do you have some data, but um, are you going, well, in every scenario, but in a scenario like this, it's clear that yes, you had the data, but the question of will you continue getting the right data to be able to um, uh, keep the service up, right? Because this is a scenario where if you are not constantly getting data and you fall behind by even a few months, your model can go off. So if you are dealing with this now, you better make sure and be cognizant that yes, maybe someone dumped this data somewhere, but you don't even have data pipelines. And maybe to get this GPS data, you have to jump through all sorts of hoops, right? But they've got you this 2 years data, right? Well, you better make sure that when you're going to production and you're going down, there's an understanding that all these data pipelines will need to be set up. You need to be able to get even future data at this speed, at this let's say frequency rather than speed, in this quality and so on and so forth, right? Um, if the data is coming in is very messy all the time and people need to clean it, then that also has to, whatever whatever um, is necessary to ensure that yeah, still not only do you have quality data, but you continue getting quality data. It's something that you seriously have to consider. So let's hear data readiness is just not just do we have it, but also often, let me put often in there, can we keep getting it? And will we notice when it stops being relevant? That's in not only as in referring to the data that we currently have, that yes, we're happy with it. We feel so proud that we have this data. When it's not relevant anymore, maybe now we've even used it, we're getting good results. We've even gone to market, we're getting good results. But if it starts being relevant, will we know, right? And how would we know, right? Um, so that brings us to the fourth uh, grouping, I guess, of risk um, about certain implementation risks, right? Uh, so for here, there's a line here about is this a model that works or a product that works, right? So number one, speed. How fast does the answer need to come? Within a second, hour, day, right? The integration, right? Where or in what form would the answer show up? Is it a certain screen, a certain WhatsApp bot that also needs to do certain things and have certain integration with the system. Is it a report, right? Um, the cost, right? What is the budget when it comes to training, but also per prediction, running it in actual production. And again, all these things, especially speed and cost, they are tied together. So often, if you are willing to blow all your money, you can get the speed that you want, certainly, right? So all those things have to balance. Now that's a bit of an exaggeration, but you can get speed to often a very good place, if you're willing to have an infinite spending, is what I'm saying. But certainly you're not going to want to have infinite spending. The monitoring, right? There is a risk. Let's say, talking from the side of risk, is there's a risk that we are not going to know how the model is operating, right? It's a risk that has to be acknowledged and mitigated. Again, the previous thing, for instance, this you can look at you can tie it also into the data drift and those things that could happen that we spoke about, right? That clearly we need to be able to monitor certain aspects of the model, even as it's operating, to gain some insight into certain key metrics as I identified earlier. That otherwise, how would we know, right? And then also support, right? That in real life implementation, if the model starts misbehaving and we need to roll back, can we roll back? I mean, it's easy to say, yes, when when we are using a model, if we are going to put an upgrade, if the upgrade is not good enough, roll back to the previous one. But in the real software systems, well, this is a real mechanism that will need to be implemented, and tested and made sure that this kind of downgrades, for example, could happen gracefully, or can the system even be stopped or brought to a halt, and also and so forth. And like discussed earlier, the stakeholders and the scenarios under which certain decisions are also made, especially those edge cases or those risk scenarios that you can identify, because then again, this is just the real world, right? You need a game plan for when things go bad. It's not when things go bad and now you think of what to do. In the professional world, um, you often, if you've done a good job, when things go wrong, you are supposed to already have game plan with responsible people, systems in place that just kick in, and and it's something that is an organizational policy. Yeah. So putting it together, just like with the success card, it is quote unquote risk radar. You could think of a risk radar by looking at the impact, that is, who is affected and how badly when it fails. Model readiness, is ML the right tool today? Data readiness, do we have what we need? Can we keep it? Can we use it? Can we continue getting it if that is required to make sure that we are able to keep the model performance? And implementation, can we actually run it, right? Again, LLMs nowadays as a perfect example, because just Google the best performing open source LLM and look at how many server racks you need in your house to host it, right? Of course, not everything is an LLM, but there are also like computer vision is actually quite relevant on, are you processing this video on a server, or are you processing this video on an edge device, right? Um, because if I have an gaming PC with an or a deep learning PC or a server with GPUs, right? I mean, clearly, I would be able to do far more computation than if I was supposed to run the system on a Raspberry Pi, right? So those factors also have to be um, taken into account. For instance, you might be working on a machine learning problem where you are seeing a lot of literature where people have been able to solve this problem, but you notice from the literature that all these models are running in the cloud. But now you want to create maybe a health device that does this computation even when there's no internet and so on, maybe because our local environment has those challenges. Certainly, then there's a risk of, okay, will we even be able to get a model efficient enough to run in this scenario and so on and so forth. I mean, that doesn't mean you shouldn't try, but it's a risk, right? And when it comes to industry, every risk needs to be acknowledged and is, and catered for. So an example of a risk radar, again, there are many different ways of looking at it, but I thought this might be just a useful way of, getting some good perspective. So for instance, we have a machine learning model that's designed to flag students at risk of failing a course, right? So let's say now we're looking at the impact pillar or impact segment, right? So the impact, okay, it helps lecturers. This is great. So we'll give it a green. But a wrong flag maybe could discourage a student. Okay, it's okay. Well, that's fine. I'll still give it a green. But let's say because in our past data, a certain hall, we know that those students are underrepresented in our data. And now that's a more serious issue because we spoke about risk of in certain demographics, certain groups, these things silently happening and people are suffering, being cheated, underrepresented, and everybody's happy thinking, wow, we are living in the future, right? Um, so I think based on that, we might give it amber, right? That honestly, so there's a possibility that this model might be unfair. So what that also tells us is that we are going to put quite some significant effort into now thinking, okay, what metric is going to tell us whether it's unfair and so on and so forth, right? Model readiness. Okay, so we have looked around and we've seen that similar models, okay, they exist in published work, right? We've also seen that a simple rule, even from literature using attendance and assignment scores, was already clocking 70%, right? So um, we can decide that, okay, based on this, there are similar models in a similar field. In fact, a very field, just that it wasn't our university. So let's borrow that technique. We could borrow that technique, we could adapt, we could build on it. So this looks like a prime scenario where, okay, in our sector, it's been solved with machine learning. There are some even baselines that could show that yes, the performance is already quite, even the business performance at 70% is also quite good, right? So let's borrow it up. So let's give it a green. To play devil's advocate, someone can also say that, okay, um, this green, it depends because if a simple, now we have to go back and look at, okay, what are our success criteria, right? If our success criteria is that we want to have 60% of, let's say, accuracy, right? And we know that a simple rule using attendance per assignment scores already works at 70%, right? Then we now can also think of, okay, maybe it could be amber in the sense that will it really give us the benefit that maybe the extra cost and process will bring in? But in this scenario, let's say it's green. So data readiness as well, right? So, okay, let's say we have 3 years of grades and attendance, right? And labels exist, right? And we get this information every semester. So this is great, green, right? Let's give it a clear green, right? But then, wow, a caveat comes in, which, like I said, a lot of times, an engineer, you're bound to ignore it. There's something called DPA. I think D is for data, P is for protection, I assume A is for act. But with that one, we haven't obtained it yet, right? And that's, of course, is such a significant thing that brings us back to amber. Now, the reason why it's not red is, let's say let's imagine that is the computer engineering department working on this. So based on what we know about data protection and those things, maybe we are likely to get that some consent, right? Um, so we feel that maybe we feel that even though the students might have to consent to the usage of their data. Let me just bring an example out there. Yes, we feel that there might be some back and forth, so we might need to educate students that no, this data is purely used to help you. It's not going to be used to maybe decide who, um, maybe there'll be some opportunities that, if you people might be thinking once you start doing these things, there might be some opportunities that you're not telling them, but they will not get if you are reading them wrong. So you might need some sensitization and so on, so that maybe, but we believe that once we do that, the students will consent. So we will say, okay, Amber. Then when it comes to, let's say, implementation, realize that, oh, we've been so excited as a department that we are coming to do this machine learning model, and we know we have a lot of machine learning expertise and we have the data and we're going to get this done. But now that we've sat down and looked at the risk radar, we've realized that when it came to implementation, we know that we have a student portal. We have not thought about how we are going to integrate it there. We've not thought about maybe how we're even going to host the model. If the university is going to use it, where would they even host it? This model might not require GPUs, but let's imagine that does the model require GPU? Does it require certain compute resources, right? And will those be available, right? Does the university maybe say that anything that deals with our student data has to live in a certain data center? Who knows, right? But the point is you should know. So if it's who knows, that's a problem, right? Who is going to monitor it, right? Um, if things go wrong, what is the support or what is the action plan, right? When various scenarios happen, let's say prediction goes wrong, or let's say, excuse me to say, you see that a student, maybe they found them, they said they want to do something drastic to harm themselves. But why? It's because they've been struggling and the system even told them that they'll fail, right? What do we do when those things happen? As now a scandal comes, how do we, um, again, maybe the example is not too um, certain, but my point is just that, for instance, if you realize that this model has, like we said, could be unfair and could cause distress to students, then if in the real world this is to come up, how will we react? And who will be responsible for the reaction to that, right? So those are also key because when you're looking at the machine learning model, um, at least from the industry perspective, now it has to operate in the real world and it has to be beneficial in the real world, and it also has to not cause harm in the real world, right? So that's quite relevant. Um, so this brings us to the end of this talk, right? We looked at, again, defining success, reading the risks. In summary, for the success side, we saw that we can't just use anything for success. If we can have a scenario where we've gone to do a machine learning project, and out of the deceased leaves, we have identified exactly 0 of them as deceased, and therefore none of them have been sprayed by, let's say, a very intelligent drone. But yet we can go and say that we have 99% accuracy. We are geniuses if we are not picking our metrics properly. And we also have to know what is good enough for the model to launch. What is some realistic vision that the team is driving towards, that once this is done, this is a very solid model. Maybe you can say that, okay, I have a system that is reading license plates in a parking lot. And when you have 99.9% accuracy, this is great. The risk is acceptable of the few issues that may happen. And now we have, as we define it, a robust system that we are happy with. So then we say our goal is to get 99.9%. But we know that when we launch, but we are working, now we're at 60%. But when we know that once we get to 85, we can launch in our pilot based on risk. Or let's say, in this example, let's say once we get to 99, right? But sometimes it seems that 99 is very close to 99.9, but when you multiply by large enough instances, the number of people affected becomes quite wide, right? So we could say, oh, we are now at 80. Once we get to 95, we will now be able to bring it to the market on 99. But ideally, 99.9 is our ideal scenario of accuracy. However, once we also put this model out into the market in the medium term, maybe we expect to get more data. So the goal or the expectation is for us to get to this point. Or maybe we acknowledge that in the real world, it could drift slightly from our test data. So we are expecting that within this band of tolerance, it could deteriorate a little bit, but these are the acceptable bands and so on and so forth, right? Also, when you're defining success, that is easy, right? It's much harder, especially in being excited and wanting a project to succeed, to actually write out all possible failure conditions, right? Some might argue it's maybe even impossible to write all out, or maybe to make okay, it might not be impossible to get right all out, but there's this thing where you don't know what you don't know, right? So even though you've written all your failure conditions, you can never be sure that you've truly exhaustively listed them. So it's important to be careful and not just, be a bit callous and say, well, these are the risks I thought about. Let me move on. Be very aware that it's a blind spot that you really have to catch yourself and force yourself to not be overconfident, right? Um, on the risks, we looked at several, at least the four, risk grouped into four areas. One, which was the impact, which was, yes, people benefit, but people can also get hurt. People can also get left out of the system, right? Like in the example I gave where the lending company trained on Accra and Kumasi data, and now people in the north were getting less approval, even though in this scenario, their whole Ghana base, their loan approvals overall were going up. The people were happy, the Ghanaians are happy, the company too is making more for profit, but the company is happy. But there's a section of people in the north who now they're not paying, you can't pay school fees, their businesses are not going as well as they could because they are not being they are an Accra man or an Accra woman can be in the same position, but they will not get a loan to better their family. But the one in Accra will get a loan to better their family only because of a very hidden thing in a model somewhere that maybe it could happen that for 5 years, 10 years, nobody looks and nobody knows. It can be very sad and serious. Model readiness is machine learning the right tool today, right? Both from many angles, right? Um, do we know from literature any instance where machine learning has been used to solve this problem based on theory and our understanding of the field? Do we have good reason to think that, well, it hasn't, but we feel that understanding is that at least we should try and experiment? Is it that based on certain criteria, rules, or heuristics might be better to start with? All those things need to be considered. And again, the risk side is misappropriation of resources, wasting of resources, and so on. Then data readiness, right? One of the risks is not having good data readiness, right? Not having the right data, not having the right labeled data, not having fresh data, or the risk of having outdated data, the risk of having data that has somehow is no longer representing the distribution that you think it is in the real world, or even data that it might be right there. Sometimes in industry, you can have a very tempting scenario where the data is right there in your database. You can look at it, but you cannot use it. And and you have to be aware of those things as well. Um, and then finally, implementation. Implementation comes with a lot of consideration. Um, Four of the amounts I've highlighted here, and which come to my list, from my perspective, are speed, cost, monitoring. So the speed being in the real world now, be the real world constraints, can your model actually meet the demands of the speed with which it might respond? cost. Are you going to be able to bear the cost of all that training, resources, personnel, data, all that to be able to train the model, maintain it, and serve it, right? Monitoring. Are you going to so again, well, if you want to look at it from the risk side, then the risk is you have a perfect model, but it will be too slow. Or you have the perfect model in the lab, but now you put it into practice. Let's say you're using it to score again. Let me change the story. Use it to say cattle, maybe cattle who are showing some sickness, the way they start to walk and look, maybe from there's some um, system that can analyze it. So you do it in the lab, perfect, it's really great. Now you have to go and put 100 cameras, 1,000 cameras, or let's keep it 100 cameras across the place. And you realize that, hey, there's one thing to run it, or even one camera, it could be that it's one thing to run it for a few minutes to prove to Dr. Mills that you've done the job. It's a whole other thing to now say that we are going to run this thing 24/7, right? Um, it could end up being cost prohibitive, right? So there's a real risk that you do this and then you'll not be able to, whether you might, whether in the middle or at the end where you move it to production, you have to make sure that you are aware of the cost and can actually take this journey. Otherwise, you run a risk of hitting some cost barrier. Monitoring as well, there's a risk of not knowing what is going on, right? And there's a risk that things are going to be happening with this machine learning model and it's going to be impacting the world, even with who is left out, right? Now we realize that some people can be left out. So we've designed metrics that, oh, wow, this metric, once you are able to calculate it and really look at it, you can tell that this group of people are being left out. For instance, yes, you have your overall accuracy and your loan approval rates, but for every single jurisdiction, based on maybe in Ghana, we know that regions are a good way of separating people. So we say for each region, we're also looking at how your loan approval rates are going. If we don't realize that there's a risk that people will be left out, and we don't realize that there's a risk that people will be left out and will not know, we will not make sure that we have the right metrics and we have the right monitoring in place to really tell us when some of these things we've identified are going to pop up, right? And then support, right? That's another risk. Model like I gave an example where like loan company put a model into production and now it's starting to deteriorate. And now they're having conversations every week. They'll go to management meeting and come with, is this good? Is this bad? Is this maybe a noise in the data? When these consideration of how you're going to analyze a scenario, how you're going to determine whether it's noise and whether you're in trouble, should have all been decided. And also those responsible for making the call and the protocols um, in place to be able to deal with that problem, right? You need to obviously be in place. Otherwise, you run at the risk of, yes, and so they're related in the sense that yes, so now you mitigated the risk that you don't know it's going wrong, but if you now you know it's going wrong, but you haven't planned for it, right? That's also a risk because now the alarm is going off and you don't know what to do. So in short, these are a few of the things that I'm very happy that I was able to meet with you guys and share with you. There are certainly other considerations that you can think about and possibly, right. These lists and points are by no means completely claim to be exhaustive, but the hope is that at least it's giving you a bit of an insight into perhaps how certain things, certain considerations might be taken when it's looked at from the perspective of industry and solving real world problems from a bit of a higher level overview that now, as to my understanding, in your subsequent lectures with Dr. Mills and other lectures, they are going to dive much deeper and get into all the technicalities and really be able to bring machine learning models to life. So it's been great, and thank you for having me.
Okay, Jerry, thank you very much for the presentation. So we'll now open the floor for questions. First, the material that he has shared, we will put it on the page for you, both the PPT and then the audio or the video as well. But the last Wednesday, there were some questions that you gave out that we said individuals should try, and then we will do some random selection of 1 or 2 people to share their what they did. First, let me open the floor for questions. If there are no questions, then if somebody has done it and person wants to share, we'll give the room for it's there with 20 minutes. We'll give the room for that. Otherwise, we'll deal with it next week before we start the discussion, because we want to be sure that people are following, not just you are attending and listening, that is it. When you do something, you must put it into action. At least it helps you to know whether you have understood it or not. So we've opened the floor for questions now. At least Jerry will come back at certain point in the development process of the model, so on a particular topic. But for now, he's dealt with what he has to do. So please, if you have questions, he's here for your questions.
All right, I think Na has.
Now, please go ahead and ask your question.
So please, for example, if you have a fintech company and you're using an ML to make people's credit scores, determine who you give loans to and who you don't give loans to, and like the ML is disproportionately like I don't know, like it's not fair to a certain group or class of people. Is your company that uses that ML subject to like lawsuits and stuff like that? Or it's just like a personal decision within the organization and it's like no external person can sort of penalize you for it?
Thank you. So, how do I put it? So it's you should certainly do it out of the goodness of your heart, right? But some of the things too is that, I'll not deny that, of course, we at IT Consortium, take utmost care and perfect care. Okay. But of course, there are scenarios where in Ghana, if you are lucky, you can get away with doing certain things. And even though you find that, yes, there's a lot of talk and a lot of even in writing against this discrimination, right? It's currently not enforced, and it's currently at a place where, frankly, to my knowledge, it's not being monitored to the level that we would like, right? But you have to also keep in mind that some of these things, you are doing it because, well, obviously it's the right thing to do, but once you get, there are some things that, yes, there might not be a flag somewhere that the Bank of Ghana has that immediately start, your model is somewhere discriminated, they're able to catch it. But if there's a suspicion and someone is to bring a case against you and you were to become under investigation for some reason, right? There are things like investigative journal. I mean, that's a good thing with the investigative journalists and stuff like that. So it's things that if it happens, people still can find out and bring against you. Also, I think most importantly, because we know the right thing, we know where also our systems are going to have to kind of catch up with, right? So you know that inequality It's a major thing, even from the UN, even the World Bank, and globally. It's a major problem, right? So it is highly likely at any moment that more and more of these laws are going to be more concrete, be more specific, and start to perhaps be even implemented more, right? So it's better to just, in my view, to to um, to do the right thing. But if the question is currently, can people discriminate in Ghana and get away with it? The sad part is that globally, it's one of the challenges of machine learning and what a lot of activists are really trying to bring to people's light. But I mean, even it's difficult for us to care about these things. But um, yes, it's a problem. It's a problem in machine learning, right? It brings up an interesting question of how many systems are out there in the world, even now, that are discriminating against people, right? We hear of police surveillance, facial recognition. We can hear of success stories. It can help to inform that even in those scenarios, at the back of your mind, you could ask yourself that, yes, we're hearing success stories, but are there some demographics silently suffering, right? Um, I don't know if you answered your question, but if you have a follow-up, maybe you can let me know.
Please, any more question? Any more question? The last call. Any more question? Okay. So if there are no more questions for Jerry, please thank you very much one more time for the presentation.
It's
So
my
now
pleasure. Thank you very much.
okay. So now I come back to the team. Next week, Wednesday, we are going to start with the programming. We are going to start with the programming. And the programming, we have shared the installation processes and a short video of how to go around the installation on a platform for individuals to make sure that, because it's not a time that when we come, we are not going to start how to do the installation process. So we have put it in advance that at least from this weekend all the way up to Wednesday morning or Wednesday afternoon, before we start at 4 o'clock, let's make sure that we have all done the installation and all the necessary libraries that need to be installed. You'll have done that. If you haven't done that, at least we will spend just 5 minutes or 10 minutes to do that. If you don't have a problem, we'll not be able to attend to you immediately because we are starting. So if you do that and you have a problem, then when we start, we will call for, if you have a problem, we'll deal with it before we start. So that is number one. And then number two, I want all of us to try individually to try and solve the question that Jerry put up last week at our last Wednesday meeting regarding machine learning problem formulation. When you have a problem, what makes you convinced that you can use machine learning to solve that problem? What are the flags that you need to look out for to show that indeed we can use machine learning to solve this? And then today we have been taking through one of the sources and then also the risk. So if you have done that exercise, then you now ask yourself the second, what success measures will you say your machine learning model would meet? Is it going to be successful? If yes, what are the convictions that you have there to be successful? If no, what are also, because you are trying to make a decision, and that decision, it is not, oh, I was asked to use it. I was asked to use machine. That's why I'm using machine learning. So we want to avoid that scenario because as engineers, I mean, I'm sure you mentioned it at the industrial level. There's nothing like you were asked to use it. You take full responsibility of your action. So you come up with what you want to do, and then you'll be asked, why did you decide to use this? And as an engineer, you have to clearly show the reasons why, if you call it your justification for doing what you are doing. And then to tie that to the last question that was raised in terms of fintech and then some crude way of doing things. You can do things, yes, like Jerry pointed out, you can do it. But if you work with a fintech, then you know that you are governed. You are the engineer. Maybe if there's a problem, it's on you, the central bank that monitors and regulates your activity. They will not be dealing with you directly, but they will deal with your institution. They will close the institution down. They will blacklist. They will fine. There are different things that they do. One of it is they can fine the organization, and they can also suspend you for maybe 2 years, 3 years. So if the company is suspended for operation, then who will pay you? The engineer working. So a number of things I mean, for engineers, you can hide behind things and do things. But when you are caught, there are implications from legal implications, criminal, all the way up to whatever it will go to. I know I've heard of cases where some people working in the financial sector had to manipulate. They were caught. They have been jailed. I'm sure some of you have been following news. You hear some one or two people were involved in some fraud working in the bank, but they are not engineers. But because for the engineers, you play with the system itself. So when you have developed an AI-based solution or something and you tweak it, you by all means be caught. You may go away today, but tomorrow you'll be caught. So ethics is the rule of the game. As an engineer working, you have to follow ethics. Professional ethics is something that you should be guided by. When you ask you in the university, when you are doing work and you say, oh, I've done this solution, sometimes people are only interested, oh, it is working, it's not working, that is it. But at the industry level, it's a different game altogether. So please take note of these things and then try and learn how you can define a problem as a machine learning problem. And then what the risk will be, and then what the successes will be. On that note, we close for today. If Ken, you have any closing remarks, you can go ahead. Ken, if you have any closing remarks.
Bro, I don't have anything to say for today.
Thank you very much. So we have closed for today. And then if you have any comment or questions, you can share it on the platform. And then if we can answer, we'll answer. If we need to bring Jerry back to come and answer for you, we'll send it to him to respond and we'll put it back to you on the platform. All right. Thank you very much and have a good weekend.
Bye.